down.
All right, cool. So we wanted to start out with something that I saw a couple of weeks ago. Chris of Veracode was talking about their State of Security report. And some of these facts stood out for me, which is things that us security people don't really think about. The first one being that the recency bias for developers. We think about, we put a lot of time into prioritization and all of these things, and then developers seem to just pick up the most recent bug and fix it. The second thing was the automation piece really does help make security a habit rather than things that they need to do on the side. And the last one, which was interesting to me, was driving down security debt. Every company has security debt, and automated frequent scanning seems to help make the security debt go away over time. So all of this and a lot more is in his Blue Hat talk. Very interesting and lots of data on there. The goal for us really was to change our culture at Dow Jones. A few years ago, it was really around we develop code and other people do security. So how many of you have a similar problem in your organization? Show of hands. All right, cool. So this is a common problem that we all deal with, where security is thought of as a secondary thing. And then that leads to problems by itself, which is increase in vulnerabilities, ballooning security debt, et cetera. And what we are proposing is this automation is going to help change that culture as a whole, not just fixing and bringing down the level of vulnerabilities, but wanting people to do more security by themselves. So last year at DevSecCon, we talked about a tool that we developed called Hammer. It is a cloud security tool in the AWS environment, and it focused really on fixing issues. It can find things also, but more importantly, we think of it as a way to fix problems in an automated fashion so that no manual work is involved. We have been doing a bunch of work with the Uber team. They have rolled it out in some of their production environments, and we continue to collaborate with them on this also. So this year, we try to focus more on the code side of the world. What can we do in a similar fashion to reduce vulnerabilities from a code perspective, CI/CD, development, all of that? And our solution here is open source now. It's called Reapsaw, and you can find it at the link. The whole point of having Reapsaw is to have multiple tools plugged into your pipeline, whatever pipeline that may be, and you can mix and match, you can get rid of tools, et cetera, essentially a layer to plug in, but not having the devs look at every tool individually. So we are going to abstract away all of that complexity of security tooling and feed them the information in the way that they want to see. That's really the goal of Reapsaw. Now, I don't know how many of you guys will get it. I just realized that this is not the US, where this is pretty popular, but when Jennifer Aniston says, I want you to want to do the dishes, I feel like as security people, we always tend to push security into to developers, right? I want you guys to use the SAS tool, or I want you guys to scan this. But most security tools are pretty bad. They don't fit well with developer workflows. We shouldn't be asking them to use crappy tools to kind of, when they're trying to do a lot of their work. So the goal for us was to say, we want to support anything that you guys care about, Jenkins, CI/CD, I mean, Circle CI, other things. We want a low overhead. Essentially, if we can provide a service to the developers and build something for them, some technology for them, and then help them move from whatever they have today, or they're not doing any security today, but let's get into the next part, but not push them to use tools. So these are some of our design goals that we set out for Reapsaw. Now, this part is, I think this is really the crux of the story for us, is we had the technology bit, which is given by Reapsaw, and most of the security folks tend to focus on the cool technology bits, but not talk about rollout and support. How are you going to support all of this? Then you need to talk about the reporting piece. Right? So those pieces are really typically the unsexy parts of the CI/CD integration process. So we'll touch on a little bit about use the technology. The technology is cool. Ours, Reapsaw, is one example of how you can solve it. It's not the way, I wouldn't suggest, but it is one way that you can take it and use it in your environment. But more importantly, the rollout, the support, the customer service that you provide to the developers, and the reporting that you provide on it, those are all super important pieces that will make the whole program successful. OK.
So how many of you guys, with a raise of a hand, have you seen OWASP AppSec pipeline? This one. Have you seen this? Someplace or other, right? So here we are to talk about our implementation of OWASP AppSec pipeline, right? Things that have worked for us and things that you can take down and it's ready to use, right? Ready to run from day one. So this is what we'll probably talk about, the technical bits. What we have catered towards is fixing the vulnerabilities. That is one of the most important things, be it Dow Jones Hammer, be it Reapsaw. We focus on fixing the issues rather than finding more issues. We already know what our issues are, right? So let's talk about the technology bits about how do we fix and how do we find issues, right? So this is a 10,000 feet view of what would a Reapsaw look like in your pipeline. So consider this as a Jenkins or any CI pipeline. This is just one of the portable component that runs within your pipeline. You don't really have to worry about the environment, setting up the environment. My tools run in Python, Java, Ruby. Have a Docker container, load all your environment requirements, and now you can execute your tools, security tools, which are notorious to be user-friendly, right? You can use them, trigger the security scans, and then push it to developers. Right? Jira integration is how we actually push it to developers. So this is how it helps us being portable, being CI agnostic. This can work in Travis CI, Circle CI, Code Build, Google Build, or even organizations where you actually do CI manually. You can run this locally in your laptop as well. Let's take a 5,000 feet view of it. This helps us being flexible. This empowers our security team to be flexible enough to add and remove any security tools on the fly. We can try out new security tools without affecting the developer ecosystem. Developer doesn't need to know what are we doing on the back end. We have integrated Dow Jones Hammer, a cloud security tool, into the pipeline. We can integrate any other security tool. You just write wrappers or add more API layers on top of it. And there you go, you can trigger scans from this solution. So it's pretty much plug and play. In the end, all the results are aggregated and sent into Jira to developers. So let's take 1,000 feet view into what our solution looks like, right? So this is what we discussed last year at DevSecCon Boston chapter. I'll talk about how actually it integrates into the CI pipeline. And well, after the tool runs scans and will identify issues, I do want to emphasize on the grouping and analysis and what do we report on Jira part here. So static code analysis, we get all the results from the tools in different formats. Sneak will get in JSON formats. Checkmarks will get in XML format. Any custom tools will get in a CSV format. What we want to do is we want to normalize these formats into one standard consistent format. Once you do that, then it helps you do grouping and analysis, right? If you have run this particular tools one time in a day, you identify 10 issues. Next run, you'll identify 12 issues. You don't want to report all the 12 issues again. You have already reported the past 10 issues. So you only want to report the delta. So that's like grouping and analysis and deduping, right? So you become context aware, and you only send the delta part to the developers. You can't bombard them with the same issues. Do not want to create the Jira tickets again and again and again, right? So you want to solve the deduplication part. So focus on that. Make it very consistent interaction for your developers. That is one of the most important piece here. We also covered DAST, Dynamic Application Security, into the pipeline last year. What I do want to emphasize today is how difficult it is. We tried this in our environment. We are still in initial phases. Some of the challenges we faced is DAST is great, but it is as good as your testing, right? If you have good performance tests, if you have good smoke tests or functional tests, that will give you good coverage. The tooling itself is not self-sufficient, so the more amount of tests you have, the better your scan results can be. We ran it in passive mode, great. We ran it in active mode, awesome. We were able to identify issues. We start spidering. What hit us bad was that takes a lot of time. So we tuned it enough to identify how much we can run within the deploy pipeline, right? Usually we take 10% as our number to let the security testing takes 10% of the total build and deploy pipeline, right? And then we terminate it. We send the results to Jira. This is what our solution would look like if you have a standard SDLC pipeline. We have SaaS components, checkmarks, and Sneak. You can add them to your CI pipeline. We have the deploy part where we can integrate Hammer, which is API driven. You can test the environment. You can test your environment once your application is deployed. Do you have any misconfigurations in your cloud environment? You can run Burp Suite Pro. Identify low-hanging fruits. These are short scans, but important enough so that you do not have low-hanging fruits in your production. This is what our Jenkins job would look like when we actually trigger a CI build. It takes 1 minute, and the total build time is 2 minutes. Usually, our threshold is 10%, right? In this case, since all the other steps were pretty fast, it just took 1 minute to run SaaS toolings, right? This includes Sneak scanning. This includes checkmark scanning. We'll talk about the tooling part. How do we actually work on customizing the tooling part, which is important enough to get you these results. Obviously, we had consulted with our development teams and our DevOps teams, and they were fine with 1 minute delay. This was supposed, do you want to talk about this?
Yeah, you can go. Yeah.
This was supposed to be the goal of our whole security into the CI/CD. These are the activities. I think we are doing great in secure composition analysis, static code analysis. We picked up our top 5, not whole OWASP top 10. You can pick, we started with top 2. Pick what is more important, then start maturing. Threat modeling, secrets in code, those are certain things that we want to work better in. And then start working towards abuse testing. If you have good test cases, morph them into abuse test cases. That will give you a strong coverage. And then you move towards container scanning, you move towards IaaS, RASP, and all those kind of technologies in CI/CD.
All right. So a few things to note here is that when we have the SAST and DAST, we don't try to find the universe of vulnerabilities. We only focus on specific items that usually show up a lot in pen testing and other areas. So if SQL injection is a concern, cross-site scripting is a concern, then when we start onboarding an application, we only focus on those 2 things. And then over time, as we get more confident, then we'll increase the profile to include other types of vulnerabilities too. So there is a maturity curve in the way each application would go. There'll be an onboarding and then more and more vulnerabilities will be added to the profile and stuff like that. So here we have kind of our goal. The next one that we are working on is that data analysis part. So we talked about the technology piece, which is fairly straightforward to do. Now you'll get a lot of data out of the different sources. So how do you normalize, correlate, dedupe, and things of that nature? So that's what we are working on right now. And we have some ideas around using BigQuery and Google Data Studio for reporting. And all the sources that you see here, that's feeding into one place to get that normalization happen. And then that will drive the reporting from the other end. So this part is something that has been a pain point for us. We don't have the full solution yet, but what we do today is essentially for each of the applications that we have Reapsaw running in, we do a lot of the work manually first, and then automate that process. So this is what we have today. We have about 25 products that go through this process today. And if you think about that first slide I showed you, the Veracode report had us saying you get about 3 times more fixes when you have automated scans. And what we are seeing is about 2x improvement compared to the earlier setup. And the false positives and the won't fix is about 20%. So half and half, I would say. So the false positive rate is about 10% because we do a lot of work initially in the onboarding phase. Now, for the process part of it, if you have the regular code deploy, kind of the pipeline model, so we don't jump in and deploy this in the pipeline. What we do is we do some analysis on our part. We get the information. We have our team, the product security team, looks at it, runs initial scans to see how many false positives are there, what is going on, what are the kinds of vulnerabilities it's finding. So there is work on our side to clean up the data, so to speak. And that goes through a security tester finding false positives, setting up the incremental scans profile. So if you want to make your scans quick, you cannot have a full scan happening every time, right? So we have the incremental scans that happen in the pipeline. And then the third component here is tuning of the tool. So we are looking for specific types of vulnerabilities and tuning the profile and the tools, whether it be checkmark, sneak, et cetera, to find the exact kind of things that we are looking for. And the whole goal being that we need to find all the low-hanging fruit in this scenario. Again, we don't try to boil the ocean, but the low-hanging fruit, easy to find, quick to find, we want to find those in the CI, and then the more complex stuff, we leave it to other steps outside of the pipeline to find it. So when all of the analysis is done, then we go in and do the Jenkins integration. We do this ourselves. We don't ask the developers to do this because, again, with our security culture, we don't want to give more work to the developers. It's easier to make friends if you say, hey, let me do this for you, and you'll find this useful. So we do the initial Jenkins integration, and then, like we mentioned before, the bugs start flowing into Jira, and that's all they should see. The developers don't necessarily see the work that happens in the background in that initial phase. OK, so what we can do today is about 1 to 2 applications per week. When we initially started about a year ago, we were taking a few weeks to onboard and set up the application, et cetera. And now we are converted it into a lot of an operational work. So we can do about 1 or 2 applications per week right now. From a feedback and review mechanism, this is super important because we always go back and check with them. Every quarter, we talk to them about what is going well, what is going bad, and they tell you, like, oh, there's lots of false positives, or you broke my build, et cetera. And that, for us, is the feedback loop so we can make the automation better. And the last piece of this is the reporting piece, which admittedly, this is our weakest point today. I think of reporting in terms of 3 different levels. There is the tactical for engineers. There is the product-based, which is for somebody like a product leader, somebody who should be knowing about what are the risks in my product. And there's a strategic one where the CTO, the CISOs would be more involved in. So the tactical for the engineer stuff, we use Jira internally. So these dashboards are built. We're doing pretty well in this because we have all the data there. We can give a view to the developers, and we do pretty well with this. The next one around product-based reporting, we're not so good. We are still trying to figure out what should be the right way. We tried heat maps, not that great. It did not stick. Another thing that we are trying today is this concept of bringing all the vulnerabilities together, all the infrastructure ones, the cloud, and the application layer, all of these together correlated into one dashboard. Again, it's a work in progress. You'll probably see a lot more of our success story on the reporting side, maybe 6 months down the line, since we are actively looking at it. Happy to talk to anybody who has success in this area, because we are trying to learn also. And then lastly, the strategic reporting. That's one place where we don't have a good view on, and that's something that we are actively working on also. So bringing the business context into this so that a CTO can really assess the risk, not just giving oh, you have 50 vulnerabilities on this product, but what does that mean? What does it mean to the business? So those are the areas that we are good at the technology part, we are good at the support part, not doing so great at the reporting part, and we are making progress in that area. And that's it. So wanted to leave some time for questions so that, feel free to ask us anything about success, failures. Happy to have discussions around any of those.
Sorry. Yeah.
Hello. Yeah. I saw there was a threat modeling module also which you showed. Can you elaborate more on that? What specifically, any tool or what you used to do in that phase?
Yeah, the threat modeling, I forgot to mention that earlier. The threat modeling specifically, it doesn't go through the technical CI part, but it goes through the reporting part. So it's the way in which that information is fed in is the same data analysis. That's what I should have made clear earlier, is that it's kind of similar for the bug bounty stuff, et cetera. The bug bounty information that we get, it gets fed through the same channel, so it becomes a different input into the data analysis, and it gets collected on a per product basis. It doesn't go into that Reapsaw type of CI/CD integration. It uses the same data model in the back end.
It's an out-of-band activity, basically. Oh.
So you sort of spoke there about the technical aspects of what you were doing with the pipelines, but can you tell us a little bit more about how you actually worked with developers and product owners to sell it to them?
The biggest selling point for us was telling them that you don't have to do any work. We are going to take this on and integrate into the pipeline, and that was the biggest win for us, because we had tried the other way before, which was, hey, we have this technology, can you guys integrate into your Jenkins? And they would never do it, because it's one extra thing that we are pushing on them. So that's why we have this model today where we go in and talk to people, find out about all the information. We get access to their Jenkins, send them a PR, and they validate the PR. However they want to have it, they make sure that it's OK. And then that kind of onboarding part helps them tremendously, because to them it's like, oh, now I have a checkbox that says I want to run check marks or sneak, and that's it. So that we wanted to take away all of the excuses for not doing the work, and that hence we had to do it ourselves. But on that note, I have to add that more and more as we are doing this, developers are coming to us about, hey, I heard about this Reapsaw thing. I want this in my environment. So they're starting to ask for it, which is a great sign. I see that as the cultural change that we were hoping for.
One thing to add over there is when we do onboarding, the initial onboarding with developers, when we get information, we do tell them that we are not here to break any build, right? So they do get a snapshot or analysis about it, and it is their decision. So we empower them to go ahead and either stop the build or move on, right? So we make them comfortable about these toolings. We also, when we do this manual testing and configuration, we also give them numbers that they should not take more than 2 minutes or 5 minutes or 10 minutes. So they have certain things, right? And when we actually do the final walkthrough, we walk through them about these are the 5 bugs that we have found so far. This is how you can fix it. And going forward, you will be able to see these type of vulnerabilities in your pipeline. So that we have kind of done enough hand-holding and trained them, made them comfortable when they are actually looking at these type of issues. So that's like a manual work on the backside. It's a typical white glove service, so they don't have to really do anything on their own.
Okay, thanks. And just one other quick question as well. Do you use this for any kind of compliance processes as well? So is this feeding into any compliance teams about, should this be released to production, shouldn't it, things like that?
No, we have not done any of that so far.
Thank you. How many people do you have working on onboarding, and what are the steps? So it takes a week, and where do you see you can, shorten this time frame to maybe a day or?
Yeah, so we have pretty much one person in person hours. There will be one person to do this kind of work. There are different people involved. They do pieces of it. But that's one thing that we are thinking about around the scaling part of it. If we can, it's essentially a tiger team in a way, which goes around and does this for different people. And budget constraints and all of that, we just have that one person who does this in a serial fashion, but it is totally possible to parallelize the whole process and have a bunch of people doing this at the same time. And that's where it's important to mention, too, that when we started to figure out what works, what doesn't, it became a checklist exercise at some point. After a few months, it's like, OK, this is how onboarding should work. These are the steps you have to do. And it becomes much easier to do that parallelization.
So the one person you have, is that the same person that's removing the false positives and doing that kind of manual work to get a clean set of results for developers?
Could you repeat that, please? I did not quite understand.
Yeah. So you mentioned you had one person doing onboarding. How many people do you have doing the kind of manual work to remove false positives and provide developers a clean set of results that they can then work on?
Yeah, this will be that one person. So there is a security engineer type of person who is doing this work. I would say about 50% effort goes into that. To doing that false positive reduction. Now, the important thing is that we are only looking for certain types of vulnerabilities, and we focus on things that are either critical to the business, something like a SQL injection kind of stuff, or things that the tool is really good at. So, check marks, for instance, I can say that it works pretty well in .NET and Java to find injection issues and XSS issues. It doesn't do so well with Node.js in finding XSS issues. So knowing your tool, you can say, I'm going to look for these things that the tool is really good at. And then that automatically reduces a lot of the false positives. And that's the initial start for us. So the person involvement is less because of the constraint we place on ourselves. And over time, we'll slowly increase the list of vulnerabilities that it finds. But if it is something that is like DOM-based cross-site scripting, it's pretty much, or blind SQL injection is 90% of the time it's a false positive. So we don't do that check in CI, but we depend on other parts, maybe in the pen testing activity, to find those kinds of issues. So the way we think about it is really, what can we find in CI with a lot of confidence, very low false positive rate, and then depend on other parts to find other types of vulnerabilities and issues.
I think that's all then. Thank you.
Cool.
Thank you.
Thank you. Thanks a lot.